Ladies and gentlemen, welcome to the Dronecast, where we explore different topics and areas within the expanding drone industry through conversation with experts, ranging from entrepreneurs, educators, business owners, and on-the-ground operators. Today we have two guests, and we're going to be talking beyond visual line-of-sight operations and everything that comes along with that. Welcome Dylan, welcome Kyle. Why don't you guys take 30 seconds and tell our guests a little bit about yourself and your background.
Dylan, go ahead, my friend.
Yeah, so my name is Dylan Busby. Jackson, thanks for having us. We're real excited. I work in business development and do some flight here at Census. I started about 7 months ago. I work under Kyle, essentially. Kyle, you want to go ahead?
Yeah. So again, Jackson, thanks for having us on. Same kind of story, Embry-Riddle graduate, business development side at Census. I started with Census like 4.5 years ago. And it's been a wild ride. So, again, thanks for having us on. Obviously, BVLOS is what we've sort of built our niche around over the course of the last several years. And, actually really since inception. But over the course of the last several years, there's been a really good story to tell. So, appreciate the platform to do so.
Awesome. I appreciate it. You guys are some of the first guests, so welcome on. And hopefully we'll have many more moving forward. But I really like this topic in particular because it's something that our industry is going to have to adopt. And it's one of the ideas which really expands the capabilities of what drones can do moving forward into the future. So why don't we get started? And we'll start with the first question, which is, tell us about your company. What was, what was the idea behind it? And what kind of niche or problem are you guys addressing?
Yeah, so I'll take that one, Dylan. The organization was really founded on maximizing capability per dollar with commercial unmanned systems. So small unmanned aerial systems. So for reference, we don't make Textron type products. We don't make DJI type products. We're kind of in the middle. And obviously a big piece of that beyond the hardware is the regulatory permissions to be able to make an ROI on a platform that doesn't cost $1,000. It costs a little bit more than that. So unlocking some of the regulatory barriers associated with complex operations helps to really achieve the ROI that you're looking for out of a system like ours. And there's a couple reasons why the system was designed the way that it was and why things have been bolted on the way that they have been, including things like the onboard DAA to unlock some of those regulatory things and knock down some of those barriers. But really, the more cameras and sensors and different sensor suites and packages that you can haul with an aircraft, make that aircraft really valuable. So that was kind of the mindset behind, how can we make something that is affordable, that flies for a long time and carries a lot of stuff a long way and can do so reliably and can do so at greater distances than other systems out there can. So that was kind of the mindset of, taking something that was very quasi-military, grade in terms of range, flight time, capability, but backing down price. And then, of course, you're going to back down some capability from a Predator with our stuff, right? But backing down price, but keeping the capability per dollar very high.
Absolutely. Actually, I think we should have gone into this conversation, this topic. I should have asked this question before going into the topic. I think it's a great response to the question. But, we're talking about BVLOS. So in the drone industry, let's go ahead and talk about the main idea here. So what is BVLOS and why is it so important to our industry, the drone industry in particular?
Well, if you look at aerial inspections or aerial data collection, right, where drones really make a lot of sense is flying low, without BVLOS, flying low, flying close to the operator, data quality. You can get into places that manned aircraft might not be the most suited for, depending on requirements, deliverables, terrain. I just got off of a call with a group that has to navigate terrain that could have a 400-foot elevation change in 300 feet. That's pretty risky for manned aircraft, right? Maintaining that separation between the aircraft and the line, whether it be power line or pipeline or whatever. There's a tool for those kinds of inspections. or flights or patrols or whatever, and it might not be manned aircraft, but how do you actually get close to the benefit of manned aircraft, which is the range and the miles per day, the acres per day, et cetera? It's unlocking the ability to fly beyond the operator's line of sight. Having to keep an aircraft that can fly for an hour and a half a mile away from you, and then having to relaunch at different locations to maintain line of sight is, the word not scalable is a good one to use. It makes it tough to achieve that ROI that we talked about earlier. And then as BVLOS matures, that ROI only grows because the radius extends. Now, instead of flying 5 miles from the operator, we're flying 50, and then we're flying 100, and those sorts of things. So minimizing the amount of crew required, minimizing the amount of time that it takes to inspect, fly, patrol, etc., a stretch of 10,000 miles is where you start to actually achieve some cost advantages versus things like the helicopter. Or, in some cases, Cessnas are way cheaper than people think, but, we're achieving an operating cost that's, an order of magnitude less than traditional rotorcraft. So, but we're only doing that when we're able to fly beyond line of sight.
Awesome. Fantastic. What kind of technological developments go into a BVLOS system compared to a regular visual line of sight system?
Yeah, Kyle, I'll go ahead and take this one. So essentially, it all starts with the detect and avoid system, which kind of comes from the idea that manned aircraft have the ability to see and avoid other aircraft. So you need to replace that in an unmanned aircraft. So they're able to see and avoid to replace what the pilot on the ground is able to see and avoid aircraft. So you need some sort of system to detect and avoid, which is our optical sensor on the nose. And a big part of that is also the robustness. It doesn't matter if you can detect in a straight line 20 miles ahead of you. It's got to be a pretty wide field of view in order to detect aircraft that are going fairly fast and that are in all planes of the visual field of view. So it all starts with the DAA. The next big one is kind of C2 reliability. Obviously, if you're flying beyond visual line of sight, C2 reliability is important across the board, but especially once you get to BVLOS where you're going further and you need to ensure that C2 link is as strong as possible. It's a big one. And, the redundancies that go with that are huge as well. The next one's kind of air risk mitigation, which kind of ties back to both these. It kind of encapsulates everything involved in this technology and the human factor side. It's the ability to minimize risk. You'll never eliminate risk, but it's how much can you minimize the risk of flying beyond visual line of sight. It is a riskier operation. It's a more complex operation. So what are the air risk mitigations in place? And that's what the FAA wants to see. They want to see what mitigations do you have on board, on the ground, with your team, your operational history, all that. They want to see what are you doing to minimize that risk. Once again, you're not eliminating it because risk is inherent in any thing in life, especially when you're flying something. But it's all about kind of minimizing that. And I'll kind of go back to redundancy. So you want to have multiple layers of redundancy. If stuff does happen, if this goes wrong, what's going to happen? You want to have enough that if everything goes wrong, you have fail-safes in place that will guarantee a safe operation if everything goes wrong. So that's what, our system, the Centero, it's got layers of redundancy across the board. It's got 3 compasses. It's got 3 different sort of fail-safes if there's an electrical problem inside. There's tons of stuff that if stuff fails, what's going to happen? It can't just fall out of the sky, which it won't. It'll, whether that's if you lose your C2, we talked about C2 reliability, what's going to happen? It'll RTL to where you took off from. So yeah, the redundancies are a big factor in everything.
Oh, and the redundancy also doesn't stop in the air, right? Dylan just hit really well the aircraft side of things. The redundancy on the ground and your GCS is arguably just as important. So typically the folks that are operating BVLOS with a system like ours or others are operating out of a controlled environment. So whether that be a trailer, a van, a Connex box, in some cases, right, you have a climate controlled environment, which kind of does wonders for the human factors of the operation. But in that, you have a mast that sends your telemetry up 30 feet, which is what Dylan was talking about with the C2 reliability. You're going to be operating in a wide variety of terrains with a wide variety of obstacles, trees, buildings, whatever. Having that mast to get above that terrain and those challenges within the operating environment guarantees that C2 link. And it's the same thing with a redundant ground control station. So, for our system, we have two unique ground control stations that are always listening to each other. You're operating off of one, and if one fails, it switches right over to the other. So, even going as far into the weeds as power supply, right? It's obviously the most critical thing when you're out there is how are you keeping everything running? Whether that be, in our case, it's a generator that has a 3-hour backup battery bank. Both of those things can fail, and your GCS will still stay alive for 12 minutes. So it's air risk, it's C2, it's redundancy both in the air and on the ground. It's a very complex equation that everything has to be harmonized in order to create a single safety case. If there's a chink in the armor, it will be found and it'll be exposed, and then you'll have to kind of start all over again. So it's been. And
Kyle, I'm gonna echo you there. We're talking about the technology here, and that's obviously vital, and a lot of this stuff is automated. But at the end of the day, you're only as good as your operators know how to use that technology, which is why a big part of what we do at Census and the overall safety case of BVLOS is the humans on the ground. Do they know how to use the technology? Do they understand how the technology works? Do they understand what the operational procedures are if something happens? Do they have the qualifications? Because at the end of the day, like I said, BVLOS operations are extremely complex. They are higher risk. And if the crew on the ground doesn't understand what the implications of everything that all the technology in place, then it doesn't matter. The human factors aspect is massive. And no matter how automated we get, there still has to be that's really another layer of fail-safe. The ultimate fail-safe is the human being. It all comes back to the human. No matter how automated our system is, which it is, a big part of the safety case is still who are the human beings on the ground? Are they managing their resources? Do they? It's that understanding.
No, it makes sense to me. So, for listeners who don't know some of these abbreviations, so RTH, return to home. It's a very standard drone feature, specifically with drones with GPS capabilities. C2C, command and control link. Is that the proper term? That's referring to the communication signal between the drone and the base station, regardless if it's a controller or some mobile command station. Were there any other abbreviations that we talked about in that little snippet right there, besides those two?
Ground control station being the GCS.
Yep.
Yeah,
I don't know. That's the thing about aviation, right? Everything's so acronym heavy.
BVLOS is beyond visual line of sight. Just in case, I don't know if we touched on that, but that's what BVLOS stands for.
TLA, 3-letter acronym. Got to get that one.
Yep.
But I'd like to dive into the technology. So I'm assuming you guys are using flight controllers, command and control links. Are you guys sticking with the standard technology, 2.4 gigahertz, or Pixhawk flight controllers or other companies' flight controllers? Do you guys use Ardu Pilot, Mission Planner for your missions, things of that nature?
Yep. So it's a Pixhawk flight controller. There's a overlay on Mission Planner for our system, but it is Ardu Pilot Mission Planner stack. And then depending on the payload that you're running an overlay on top of that. One program, not multiple programs, but sort of a custom variant of that to operate not only the aircraft, but the payload that you're flying, depending on that payload's nature. If it's a gimbal DOIR payload, things of that, gives you all those different camera commands and some special maneuverability there too. And yeah, you had mentioned 2.4, so there's kind of a wide variety of data links that not only have we explored, but are actively working on, from The current solution is a 2.4 gigahertz primary data link that's pushing command and control, telemetry, and video with a backup data link over 915 for RC. So that manual transmitter is still in the loop for our system. It's kind of an internal debate of do we get rid of it, because you personally, and this is Kyle Miller speaking, I don't see a reason to get rid of it entirely. If you don't want to use a transmitter, leave it plugged in the or by the GCS. You don't have to be holding it.
Yeah.
Right. There's no reason to, but that also, there's only ever a reason to use it, not ever a reason not to have it, in my opinion.
Yeah.
If you don't want to use it, you don't have to. Great. But if you have to move the plane a foot to get it on the landing pad, you have that option with a manual transmitter. In full auto, you can just move it a foot. Okay. So I think it's a nice thing. I think it's a nice to have. But yeah, it's a primary and a backup data link, 2.4 and 915. We've done a lot of work exploring cellular and sort of validating that for command and control links for BVLOS over the cell network. So that is sort of the C2 of the future. And then other, 10-mile range radios as well have been integrated and are being integrated for that for the Centero. So the data link, there's a lot of flexibility there. The payload, there's a lot of flexibility there, because ultimately it goes back to how far away can we fly as many payloads as possible.
Yeah.
So
saving time, you can always collect more data.
Exactly.
Right.
There's always going to be a customer for the data.
Yeah. So you were saying that you were exploring, your company in particular is exploring using 4G, potentially 5G, but basically cellular networks to aid in these operations. So I guess maybe we should go into that a little bit more. So what is the limitations of the 900 or the 915 megahertz and the 2.4 gigahertz signal range? So what kind of obstacles do you face towards the end of its control range, as an example?
Yeah, so typically the maximum advertised range for our data links, we achieve those through the mast. So depending on your environment, if you have it on a tripod and it's chest level and you're going to be 3 miles downrange, you may experience a degradation in data link. We've never experienced that with the mast. Getting 30 feet up, they're omnidirectional antennas. For the 6 and 10 mile radios, similar story. We hopefully soon we'll be looking at like a 30-mile data link, which is more of a limitation of our endurance. If we go 30 miles downrange, unless we're going to land there, we do have to come back. We got to come back. So unless we're flying, endurance times cruise speed, we could fly somewhere in the neighborhood of 65 miles A to B. If we have a launch area or a recovery area 65 miles downrange, that's fantastic. But if we don't, we got to come home. So we're looking at a 30-mile data link as well. A limitation there is going to be the fact that we have to push more power. We got to push about 7 watts as opposed to 1. So that'll require an FCC license, for example. So that's not a data link limitation. That's a workflow limitation. You're adding a step to the process for that extra capability. But we're exploring that. We haven't integrated it yet. We haven't sold one yet. There's a roadmap there. But I think getting away from ISM bands and onto the cell network is going to be where BVLOS ultimately goes in terms of where it goes from a C2 side. But, of course, there's a lot of validation that has to be done for the strength of the network across, right? Cell towers do really good getting connection downward. Let's find out how good they do going up, staying at 400 feet, 500 feet, 600 feet in very rural areas.
Yeah.
So, but before the FAA is willing to accept that, there has to be some work that goes into that to prove the safety case of a strong C2 link, because reliable C2 is one of the pillars of BVLOS, like Dylan mentioned. And when you're going to change the data link to something that's, I don't want to say new, but it's different, you have to then have data to support it. So that's kind of where the industry as a whole is in a fact-finding mission for making that transition.
Yeah. You got a lot of companies coming out like Verizon, pushing this narrative. The C2 link, is going to move more towards the cellular towers, which, I think in theory It's quite an interesting idea, right? Maybe at the minimum, even as a redundancy. Let's say you're 2.4 gigahertz, your 9 point, your 9.15 goes out. It'd be nice to have that redundancy of the cell networks. So besides redundancy, what are some advantages of using cell towers for BVLOS? I guess this is a little thought experiment. So this is predicated on, let's say it does work. What are some advantages that customers or individuals building the systems can reap?
Well, the first thing that goes to my head is no SD card, right? You can send your photos as you're taking them to a cloud, not processing on board, but sending it to the cloud on board. So it's being dumped the model's being made as you fly, right? You're uploading that data as you fly, or you don't have a ground. You would still, but you have an alternative way to stream live video from what the aircraft's seeing. So a little context. What Census has always done is be very concerned with how can we get, from a live video standpoint, besides just mapping and multispectral and thermal and all that, how can we get live video from the drone as far a distance away, but back to the GCS? How can we maintain a good video link from drone to GCS? We haven't gone any further from there of how do we get this video from the GCS to wherever it needs to be, whether it be an EOC or decision makers on the other coast, something like that. We've started to play around with that a little bit, especially in the last 2 months. We did a few different emergency management exercises where we were tasked with doing that exact same thing, was streaming live video back to an EOC in a simulated disaster response type of drill. And we were able to do that with success through a software-centric solution. There's other hardware-centric solutions out there that are plug-and-play boxes that are pretty sweet. I'll shout out the guys from DeGero. We met with them in Tallahassee not too long ago, and their box was pretty sweet looking, and it's plug-and-play. It works. It works, period. It's like a hotspot on steroids. It connects to a network, and you can send it in real time from the drone to the trailer, and then in real time from the trailer to whoever needs to see it. So, but cellular would be an alternative to something like those.
Fantastic. So what kind of latencies do you get with cellular networks, as an example? And
still being explored.
Still being
best way to put it. Still being explored. Obviously, it depends on operating environment and things like that.
Yeah.
But yeah, still being explored.
And I can imagine you have a similar problem with satellite internet, right? Starlink, as an example. Latencies up to 200 milliseconds or something like that. That can potentially.
That's also an interesting one. That's an interesting one too, because they're shoving satellites up into space.
Yeah.
So that'll be a reality at some point soon too. The world kind of our oyster when it comes to alternative data links to a direct ISM band.
And who doesn't like oysters?
Yeah.
All right. So let's go ahead. Let's go ahead and talk about the regulatory hurdles of BVLOS. I know that's a big topic of conversation. There's only a handful of companies who have actually been able to achieve these waivers. I think the first was American Robotics back a few months ago. So what are some of the regulatory hurdles that a company or an organization has to go through to obtain BVLOS from the FAA or a BVLOS waiver from the FAA? And how do you maintain it? How do you keep it, and how do you expand it?
Yeah, I'll take that. So the regulatory hurdles are for BVLOS they've sort of been ever shifting goalposts, but now we kind of have goalposts to meet, right? And it's always been how are you going to mitigate risks in the air, how are you going to mitigate risks on the ground, and how are you going to maintain C2 at range. If you can answer those three questions, then it becomes, okay, well, what are you flying? Technology side of things. Where are you flying? Operational side of things. And who's flying it? And that's the human side of things that Dylan prefaced earlier. To what degree have they been trained? What is the crew what's the personnel qualification? There's an ASTM subcommittee for unmanned systems that's dedicated to personnel qualification. It's a serious thing, and it's that's where the training side of, we haven't touched on training much yet, which is a good thing to probably hit now, but that is one of the hurdles, right? It might not be in big bold letters on the top of the waiver application, but it's certainly a part of every application that we submit on behalf of our customers. And having a defined curriculum, a standardized curriculum for BVLOS, a certified curriculum for BVLOS that all operators go through, regardless of incoming competency, right? It's a standardized program that we know that no matter what however they showed up in terms of competency, they are going to leave at the same point, right? It's not a hours count type of program. It's a proficiency program. So once you check the boxes, you're done. With our version of BVLOS training through Unmanned Safety Institute. So thankfully, we've dumped a lot of our training off onto partners. Partners like Unmanned Aviation Training Institute and Unmanned Safety Institute have facilitated a ton of our trainings because it wasn't what we were known for, good at, wanted to do, anything like that. Those guys are at scale. Groups like USI are at scale. They can facilitate training better than Census can. And same thing with UATI, right? So they're training companies. It's what they do best. And those curriculums have been used to outline in waiver applications to get over the regulatory hurdle of BVLOS. It's very much a holistic approach to creating a safety case. And training is a big piece of it.
Did you hear that, listeners? I hope you took that one in. That's a great answer.
Didn't pay me to say that.
Exactly. Podcast is sponsored by.
Yeah.
All right, cool. So maybe we can touch on training after this particular question, but what does a BVLOS operation look like? What does it feel like? What do you do? What is the setup? What is the breakdown? What is the in-between?
Yeah, I'll take that one, Jackson. So essentially, it's just like any other drone operation. So, pre-flight checks and all that, but you have that extra layer of complexity, and you have certain constraints. I don't want to say constraints, but certain things that, because it's a BVLOS operation, you have to be more aware of. So I would say everything you do during a normal operation, a normal safe operation, you kind of just turn it up a little bit. So you're really looking at not only the aircraft side, the pre-flight checks that are expensive, the aircraft's running pre-flight checks as well. So, you're looking at your telemetry, you're monitoring all that, but you're also taking into consideration that you're flying further. So you have maybe a closer eye on, different shifting weather, winds, you're keeping an eye on all that over a longer period of time because you are flying longer, you're flying further away. So you're kind of widening your scope of what you're looking at for the operation. You're doing, an extensive safety brief, things like that for anyone that's on site. And then obviously all the aircraft checks itself, it's a very extensive checklist for every component, and it's a redundant checklist as well. So you're doing checks that maybe check the motors here, but you're also checking the motors here. You are constantly monitoring telemetry health and all that before you take off. So that's all done before you take off. You're doing battery management, so you're keeping an eye on the battery. Obviously, there's a lot of fail-safes. As I mentioned, there's redundancies in place with the system, with the GCS, kind of telling you where your battery's at. And if you reach a point where you need to land, it'll tell you you need to land. And if you choose not to, that fail-safe's in place, that it'll automatically RTL. It'll land even if you ignore that. But still, that human element needs to be in place there of understanding kind of where the battery's at, just for kind of situational awareness. In general, situational awareness is important for all operations. It's even more important with BVLOS because the aircraft will detect and avoid any other aircraft in the airspace, but you still want to have people on the ground having the highest level of situational awareness because it is more complex. It is a riskier operation. You're keeping an eye on aviation radios, stuff like that, all the local stations, all that kind of stuff, just as you
Keeping
would.
an ear out keeping an ear out on aviation radios.
Yep, keeping an ear out.
Yep.
Exactly. Not if you're not certified, not broadcasting on it, but keeping an ear out again to raise your situational awareness of what's happening in the airspace. Because, as I said before, you are further away. It's going to take you longer to return to where you are. So another big part is kind of having areas where if there is an emergency, whether that's an unexpected aircraft in the airspace that you have to land, they're telling you to land or you should land, what are the areas within your radius that you're flying that you can land outside of the area you took off from? So it's kind of scoping out those areas. It's also having a high level of awareness of where you're flying, whether that's initially if you're flying 5 states away before you leave to go on your trip, you are looking at Google Maps, you're looking at Google Earth, you're getting a deep level of understanding of the area, down to the point where you're even using person view. It's, I guess it's street view, but you're actually going on the ground and you're seeing, if we take off from here, what is my line of sight? What do these trees obstruct me from looking at? All that, and really having that deep level of understanding before you arrive on site, so you're as prepared as you can be, and then you run that again on site to ensure that you kind of have a really good understanding. Whether that's communicating with your crew and all that, but it's really just a more extensive VLOS operation with a couple of other things in place there to kind of raise your situational awareness overall.
Yeah, I think it's obviously there's a Dylan hit on this too, but there's a different set of emergency procedures associated with it. So making sure that those are hit hard, not only in training, but literally before you fly. What are we going to do if X happens? Where are we going to go if, where are we going to send the aircraft if Y happens? If Z happens in flight, who's doing what? All those sorts of emergency procedures vary from not only flight to flight, but VLOS to BVLOS. So having a rock solid understanding of EPs is a good foundational aspect of BVLOS operations in general.
I mean, another big one as well is kind of, what are your SOPs as a company, as an organization, having those concrete before something happens. So everyone's on the same page, what you're going to do in a certain scenario, when will you land? Everyone's got different kind of benchmarks of what that is, but it's just important to have an understanding across all the operators during the operation of what you're going to do. Like Kyle said, if X happens, Y happens, and not have any latency in decision making there. You got to be able to decide quick, and latency is bad in C2. It's also bad in communication, and it's bad in human decision making.
No, I think that brings up a great point. As a experienced single operator, or myself rather, as a single operator, you go to a location. I've been doing this for about 3 years now, and so the set of standard operating procedures, the SOPs, they're almost ingrained. So I can look at the aircraft, little inspection, take it off, and go right. But in my mind, I'm thinking of places like, if something happens, where am I going to land? Or if a helicopter, comes into a particular area, where's can I react in that particular area? Do I need to be more cognizant of this area versus a more open area? And I can imagine when you're doing beyond visual line sight operations, you really have to think through those things beforehand, right? As you were saying. So what's an example? Let's say you're flying at 200 feet, 300 feet AGL. And a helicopter enters the airspace, right? What's an example of a procedure that you guys would take in this case?
Well, there's a very recent example from a string of demos that Dylan and I conducted. This would have been a couple weeks ago, but it was a 6-week trip. We didn't have a waiver for the area otherwise we would have had to file 38 waivers for this string of demos. So we simulated BVLOS. We stayed within the line of sight. Dylan was in the trailer at the one of 2 pilot stations monitoring telemetry and working the gimbal. And I was outside the trailer as RPIC. We had an aircraft inbound in our direction. It was not a factor. It was probably 10 miles out, maybe a little more. And then it became a factor. It kept flying at us. So in that situation, a couple of things could have happened. Dylan could have clicked RTL on the GCS. That would have been easy to do. Dylan could have changed altitude and flown to a different location. Point click loiter is essentially like Reaper talk, but it's the same workflow for the Centero. It's click on a spot on the map, click fly to here. It will go there, and you can change altitude, change loiter radius. You can really manipulate the aircraft in I'll call it semi-autonomous because there's human input, but it's human input with a keyboard and a mouse, not a transmitter. But to do it really quickly, we were coming into land anyway. We were on our autonomous approach when that helicopter did become a factor. So I just put it into manual flight mode on the transmitter, put it into vertical landing, and then descended and put the plane on the ground. So that was a really easy emergency, right? It was. We did something about it. We recognized the incoming threat to our flight area a while away. Had it got closer, the detect and avoid on the nose would have kind of done that for me, minus the landing part, but it would have done that for me. But before it became a factor, it got kind of close. So still probably a mile out, 2 miles out. But we were coming into land anyway, so just to expedite that landing, one flip of a switch, and then it's similar to a DJI aircraft, right? Holds altitude, holds GPS. That is our plane in vertical flight. So put it on the ground with one stick.
Fantastic.
And that was that. So that was a really recent example of a helicopter incursion that was mitigated through communication between Dylan and I, right? We're communicating via headset while I was out of the trailer and he was inside. He saw the aircraft on ADS-B. I saw it with my own two eyes. We called out the location and the heading of that plane or that helicopter. I kept eyes on it while I told Dylan to execute our east landing, for example. So he sets a waypoint to go to the east landing. We're coming in on that approach. Right before we transition to vertical flight, I told him, hey, I'm just going to land it myself. Did that, easy peasy. So that was a very good example of kind of the communication between Dylan and I, seeing different things, Dylan on the computer, me with my eyeballs, communicating about a course of action, and then any deviations in that course of action in real time. So that was actually a pretty good example for the scenario that you brought up.
Fantastic. So we probably should have gone over this in the beginning of the podcast, but tell us about your drone system, right? Is it a fixed wing? Is it a rotary wing? And what's kind of the difference between the two?
Go ahead, Dylan.
You want me to take it?
Sure.
Okay.
Be my guest.
Yeah.
Be mine and Jackson's guest.
Yeah, so it's a fixed wing VTOL, which is kind of combining the two that you mentioned. So it has the vertical takeoff and landing component of a quadcopter, but it has the forward flight characteristics of a fixed wing. So kind of the idea behind that is you're able to take off and land in a smaller operational footprint. So you're not constrained to taking off from a runway or, God forbid, throwing the aircraft. I've never heard of anyone that really enjoys any sort of hand-launched aircraft for the most part. That's not hating on anyone out there that has hand-launched aircraft, but I know it's a hold your breath kind of situation, which we know because a earlier iteration of our aircraft was hand-launched. There are benefits of that. In vertical, when you're taking off vertically and landing vertically, your power draw is about 10-1 as compared to forward flight, which again is why a fixed wing is able to fly so much longer than quadcopters, because you're taking advantage of aerodynamics. You're able to use the wings of the aircraft to propel yourself with your propellers and just to fly longer. So it is a hybrid. You're kind of taking the best of both worlds, but you're still going to have more power draw from vertical takeoff and landing. That's just a result of fighting aerodynamics as compared to working with it with the fixed wing and forward flight. But yeah, so it's a fixed wing VTOL aircraft. Wingspan is about 7 feet. I don't know how far in depth we want to go in terms of the actual aircraft specifications here.
Yeah, let's share them.
Yeah, so around 7 feet for the BVLOS unit, a little smaller for the VLOS unit. So after it takes off vertically, the front two motors tilt forward to initiate a forward flight. The back two kick off. What am I missing here? Our aircraft is a high-density EPO foam, which sometimes we get questions about. How durable is it? It's very durable. It's reinforced. It's not just a bare foam.
For anybody who's never worked with that kind of foam, it is quite durable.
It is, and it's able to. You save a lot of weight because the name of the game in the type certification arena and all that with the FAA is what's your kinetic energy, what's your energy threshold if something was to happen. And us being a foam aircraft as compared to a aluminum or a plastic aircraft or whatever else, any other material for the most part, their kinetic energy is significantly higher, so it's going to be harder for them to reach the type certification threshold. And Kyle can go into this a little better than I can. He's kind of the guy that's spearheading our type certification and that going down that route. This is kind of a rabbit hole here. You want to take it from there, Kyle?
Yeah, that's fine. So the important parts of the airplane, right? The control surfaces, those are all reinforced with carbon fiber, and they're also hardened with laminate and vinyl. So all the ailerons, rudder vaders, those control surfaces are hardened to minimize some of that. But going into what's our longer term roadmap for the Centero, right? Where it sits today is a Part 107 BVLOS get waivers aircraft with an onboard DAA, hot swappable payloads in their own modular boxes. Slide one in, slide one out. Fly for an hour and a half. Take off vertically, land vertically, transition at whatever altitude you want in forward flight. Zip around, come home, fully autonomous. With a manual transmitter option, like I mentioned earlier. But sort of what's next for us from a big, for a groundbreaking for us approval would be flight over people. Category 3 operations is a shorter burn than type certification. Type certification is obviously a process that we are undergoing. It's a longer, it's several years. It's a couple years roadmap. Flight over people is going to require a bigger parachute than what's on the market today. Not much bigger, which is really good news. There's some really good parachute companies out there that have done incredible things with ASTM certification and those sorts of things for multi-rotor aircraft, so DJI, Phantom 4s, things like that. You see a lot of formerly, that's flight over people waivers being approved with a lot of these systems for Phantom 4s. What you're not seeing is a lot of approvals for fixed wing aircraft, stuff in our weight class or definitely above our weight class. And that's because we have to get down to a descent rate that is 8 feet per second. And that does not account for any wind, which is interesting. And we'll wait for guidance on that of how much wind we have to account for. But we've been working with some really good parachute companies to do the math on what kind of parachute would a system of our weight require to get us down to that feet per second descent rate, and thus reducing our kinetic energy at impact. And that's a much shorter term. It's not cheap, but that's a cost that we have to incur if we want to continue to make this system available for the broadest amount of operations in the widest amount of areas. Again, it's all coming down to maximizing the ROI for the end user and giving people an insurmountable amount of evidence as to why they should buy our plane. Flight over people will be next. Will be the next justification for us as to why it's a good decision.
So speaking about the end user, we'll ask this question. One is what you see now. So, I know both of you did a cross-country trip. I was watching you guys as you did it. I thought that's fantastic. You had something like 500 attendees in total or something like that?
Yep. So we probably had, on average, 15 to 20 people at every demo event. There were some that we had 4. There were some that we had 30. Yeah. Doing some back of the napkin math, we had somewhere between 550 and 550 and 600 people that got to see the Centero in person. So this might have been 15 people from the same organization, but we had 600 people, up to 600 people exposed to the system in 6 weeks, which is pretty incredible. Yeah. It was also very tiring, but I'll give credit to Dylan on the scheduling and the organization of that tour. There was only 1 week where we were kind of pedal to the metal. Every other week was, even with all the travel, there was only 1 week where we had flights every single day, Monday through Friday. The other where we were, flying in the morning and driving 7 hours at night. Every other week was pretty spaced out. So we got to see a lot of people. We got to fly a lot. We got to really expose and create all these new relationships with folks that are not in Florida, right? We're in Florida. We went out there and got it. And for the most part, I was able to put up with Dylan for 6 weeks. So that was the big one.
You're both here, so no heads rolled during the trip or after.
Yeah, exactly.
So,
now, thankfully we get along well, or else otherwise it wouldn't have been doable.
Mm-hmm. So as you went out and did these demos, and obviously I'm assuming you guys have customers, right, and companies that you serve. So what kind of organizations do you find that are interested in this capability, and who's buying these systems?
Yeah, so traditionally it's been drone service providers, and then big engineering companies, and then more than anything, really, we do a ton in the electric utility space, whether it be with the enterprise or their vendors. I should say utilities in general, because there's been a little bit of oil and gas throughout there, especially as those programs start to stand up a little more. And then there's some water utilities as well mixed in there. But electric utilities is, it's when you think drone industry in the U.S., commercial drone industry, you think transmission distribution, right? It's very hot. It's widely accepted as a value add to those enterprise companies. So we've done a lot with those groups. Again, civil engineering, engineering companies in general, and then again, bunch of service providers that have big mapping jobs. So big mapping, engineering, electric utilities. But one of the very, very interesting things that we recognized over the course of that 6-week trip was, even over the course of the last 8 months, public safety and fixed wing VTOLs are starting to become one and one, right? Half of our events were public safety events, which traditionally has never really been a market for us, because the programs just weren't ready for operations that require the amount of stuff required to operate our plane, whether it be budget, personnel, training, blah, blah, blah. Right now they are. Now those programs are a couple years old. They're looking at, not only just enhancing their current fleet of other multi-rotor systems that serve a really, really valuable purpose for things like SWAT, indoor flight, all that kind of stuff. But how can we take it to the next level and scale operations to longer ranges? And those programs are in a place to do that now. So yeah, half of the stops were public safety groups, whether it was emergency management, county coordinators, state coordinators for emergency management, or your local sheriff's office. We kind of demoed for them all, which was interesting, and we'll see how it plays out over the course of the next year.
Where do you think your system, or where do you think the BVLOS system in particular, let's say VTOL fixed wing, where do you think they'll be utilized in the next 2 to 3, maybe even 5 to 7 years down the line?
For public safety?
No, not just for public safety, but kind of the industry in general. Where are some other facets or other industry niches that you think could benefit this system? Or
so I think one of the other things we kind of started to learn over the course of the last 18 months was there are some government applications for a system like ours. So talk about ISR stuff, whether it be DoD or DHS, it's a lot easier to put a Centero in the air than a Reaper in the air. And what do you have when you have a Reaper in the air, right? You have one eyeball for a very long time carrying millions of dollars worth of camera equipment and potential arms on board. But what if you could deploy a system alongside that to augment that and put 50 eyeballs in different places at the same time for half the price, right? So you can either have one really expensive, highly, highly capable eyeball flying around for days, carrying out missions that it's suited for, or you can have 20 Centeros and have 20 eyes on different targets. for a shorter duration of time, but also at a fraction of the price. So that's been an interesting shift. I know that 4 years ago, if you'd have told me that Census was doing anything with ISR, DoD, I'd be like, oh, you're crazy. That's Predators and Reapers and Global Hawks, right? It's kind of changed. There's use cases popping up, and there's business cases in a way popping up for a system like ours or others that are commercial, quasi-military, can be deployed in that environment and serve a purpose without having to cost the U.S. taxpayer tens of millions of dollars.
Absolutely. So, is anybody from the precision ag industry been interested in your systems or wildlife conservation? I know those are probably, at least the wildlife conservation is a little bit more of a niche market, but I could potentially see value in the precision ag space utilizing this kind of long range, long endurance VTOLS system for a multitude of applications.
Yeah, ag's an interesting one. So on the service provider side, we have a few folks that work almost exclusively in that vertical, from BVLOS and wide amounts of usage. We're seeing an uptick in the amount of industrial farming, industrial ag enterprises that are thinking, how can we maximize yield over the course of our 50 countries that we operate in, whether it be corn, soy, salt, blah blah blah. How can we deploy this technology to save across at our scale? And that's been interesting too. Obviously, we make total sense for folks that get X dollars per acre. We don't make sense for folks that get Y dollars per acre in some cases. So it's really a conversation kind of person to person. Is what kind of work do you have? Do you have a 5,000 acre job coming up? Do you have a $500,000 acre or a 500,000 acre job coming up? Let's talk about these kinds of things, and let's talk about the deliverable that you're giving them. And let's first figure out if we can actually achieve the deliverable. And then let's figure out what it would take to actually do that in a time frame that doesn't take 10 years for 500,000 acres, for example. So, and that's a realistic number. 500,000 acres is actually a number we've had to work with before. An exciting one. It's not a small task, but it's a task that can be conquered.
Ooh, that's big. That's a lot of land to survey.
Oh yeah.
Well, fantastic. Well, I think that might conclude all the questions that I have for you guys. Is there anything else you'd like to talk about? Tell guests, promote your next meetup or demo.
Yeah, I guess one way to go with this is we'll be out in California on July 27th for about a week. We've got a couple things lined up, but if anyone's in that area, really all of California or any neighboring states that want to come visit, or if you're close enough that we can drive and make our other commitments, just reach out to us as long as this podcast is released before that. If not, then we missed you, but hit us up, and we're always back in California. And we're always looking for kind of the next Centero tour, which we just finished Centero Tour 2. So we're kind of always kind of scoping out what's our next big tour. So please reach out to us. If you're ever in Florida, in Daytona Beach specifically, it's about an hour away from Orlando, please hit us up. We're always open to people coming and visiting our hangar, checking out our offices, checking out our manufacturing space, checking out all of that, and also seeing a flight demo. And we will throw in some good barbecue as well. And if you're not into barbecue, we've got alternatives. But yeah,
the sushi's quite good as well.
Yeah. Now, I don't know.
I'll also add that we'll be at AUVSI in Atlanta coming up. So we will be at that event. So reach out to Dylan or I to coordinate a coffee or a beer if you partake at that event. We'll be at Commercial UAV Expo in Las Vegas later this year. So coordinate with us, and if we'll have a booth there. So you don't necessarily need to coordinate a meeting. We'll be at the booth.
Awesome.
What else? Energy Drone and Robotics Summit at the end of the year in November-ish. We'll be there. And if you guys are going to be at events that I didn't just mention, ask, and maybe we'll fly out and meet you there.
Very cool. Well, gentlemen, Dylan, Kyle, thank you very much for coming on the show. It was great having you. And I look forward to what you guys come out with the future. And I think you're really pushing the envelope in what you guys are doing with your system and how it contributes to the industry.
Thank you, Jackson. I have a few recommendations for people to interview that would do a better job than Dylan and I. So I'm going to send them your way after this. They're industry folks that would be able to give a great interview, some good insight that may or may not be different from Dylan and I. So I'll send that to you.
Hey, that would
later.
be fantastic.
Yep.
Thank you, Jackson.
Perfect.
And you have a hell of a podcast voice as well. So I look forward to following this podcast as well. I hope we kick it off well.
Well, you too. Thank you very much. All right, that concludes this show. Thank you for listening, and we'll see you next time.